Hello! Before we get into this week's episode, I just wanted to give you a little plug for the eLife Ambassadors Programme. No, we're not being paid for this, though if eLife are listening, I'd not turn down paid adverts because we really need to find some way to keep the lights on around here. Anyway, just want to plug this because it's a really great opportunity for early career researchers interested in greater openness, integrity and inclusion in science. If you want to know more, there's a webinar on the 27th of October and the deadline is the 7th of November. Links will be in the show notes, so get applying now. Seriously, pause this, go apply, come back and enjoy the episode. Hello and welcome to Preprints in Motion. Join us as we sit down with early career researchers and discuss their latest preprint and find out about their journey through the muddy marshes of academia. But we don't stop there. Every month we'll be bringing you special episodes with open science leaders where we discuss how to fix academia. Easy, right? So hit that subscribe button, leave a rating or find us on Twitter at MotionPod. But for now, let's get into the show. And this week it's all about calcium channels, muscle wasting and rodent spaceflight with PhD student Jessica Braun. So I should say I am drinking this episode because I submitted a paper again today, so I'm having a mini celebration right now.
I think I should get a drink as well.
Also, I feel like it feeds into the nice relaxed atmosphere we have here.
Absolutely.
Yeah. This is more like the Graham Norton show than like the Today Show. Yeah. Everyone's got a glass of wine, it's casual.
So thank you for coming on today. And before we get into the sciencey bit, we ask everyone a fun fact, and yours was, so we've had quite a few people so far on the podcast who seem to be very well travelled, but I think you might be the best travelled person we've had on.
Really?
So it's 23 countries, 5 continents. I assume you've not done space yet, though.
I have not, but after watching Richard Branson's Virgin Galactic flight, I am hoping to check that off the list.
So was there anywhere that was particularly good to travel to? Anywhere we should all go to?
Man, my most recent one was to Peru. Absolutely loved it there. Beautiful, beautiful country, lots of history. I highly recommend Machu Picchu to everybody.
I'm up in Mexico next year for a conference. I'm trying to plan out what I'm actually going to do there when I'm not doing any of the science.
Never do.
Okay, so we are doing something slightly different to what we normally do. We've been somewhat accused of prioritizing immunology and neuroscience preprints on this show, which is not unfair because me and Emma are the ones primarily choosing the papers, and that's our background. Yeah. So we've got a bit of a focus that we want to try and move away from. And when I was looking through, your preprint really kind of caught my eye because it was different and it was really cool and interesting. So hopefully the people listening can stop complaining at me. What a way to lose listeners. So could you just give us a little bit of background on what it is you've done in this preprint? Because it's got space, it's got calcium channels, it's got all kinds of stuff going on.
Yeah, brief overview. We were lucky enough to get some samples from the 2 NASA missions, the RR1 and RR9. So we exclusively got some muscle samples. Our lab, under my supervisor, Dr. Fierro, we look specifically at a protein called SERCA. It is a mouthful, the sarcoendoplasmic reticulum calcium ATPase.
I'm glad you said that. I'm very glad you said that.
Yeah, I got it. So yeah, we look specifically at that pump in muscle and its ability to bring calcium from the cytosol back into the SR, which ultimately elicits muscle relaxation. And so we know muscle, specifically the soleus, it was designed to oppose gravity. So when you take gravity away, the soleus tends to atrophy, you lose muscle function. There have been lots of studies looking at that happening, but nobody has ever actually looked at calcium regulation here. There's a lot of connections to calcium and muscle atrophy. So we decided to hop in there and stick our nose in there and see what we could find. So we got some pretty cool data. We see that SERCA function is pretty impaired. We see that atrophy, and we actually see increased reactive oxygen species or nitrogen species, which are quite damaging to both SERCA as well as muscle in general. So we think that ties together into a nice little story and can hopefully lead some future research.
It does tie into a nice little story. We enjoyed it. So if I'm right, this isn't your primary project though, right? So how did you actually get involved with something like this?
Yeah. It wasn't initially my project to begin with. It was actually somebody else in our labs, but I was always very interested in it, and we were all going to kind of jump in at some point. So we do have a couple other studies going on with these samples as well. But yeah, the right circumstances came together for me, and I was actually given the opportunity to take the lead and do a lot of the data collection. So it was a bit of luck, me showing my interest and just asking.
A lot of how science works.
Yeah.
So getting back to Circa, does this function exactly the same in rodents as it does in humans, or are there any sort of subtle differences?
Yeah, it's pretty similar. The Circa pump is fairly translatable between rodents and humans. There are obviously considerations, especially in muscle fiber type. Rodents have an extra fiber type that humans don't have. But as it comes specifically to Circa function, it is very translatable.
And how are you measuring the calcium influx? Because there's a tiny bit of work I've done on calcium in the past. There are quite a few tools to measure that.
Yeah, ours is an Indo-1 based assay. So that's a calcium fluorophore. It has an excitation wavelength and dual emission. So we basically throw that in there with our muscle sample and some ATP to give Circa some power. And we can essentially measure with a plate reader the amount of bound Indo-1 to calcium and the amount of free. Because Indo-1 can't cross the SR membrane, that gives us a good ratio to be able to see the calcium that's actually in the cytosol bound to Indo-1 as opposed to being taken up where it's then free.
And one of the things you mentioned in your introduction is that muscle strength decreases faster than muscle mass does. Do we know why that happens? Because that, in my mind, atrophy is always that you get sort of a reduction in mass.
Yeah. So no, the mechanisms are fairly unknown still, which was kind of a big part of this study. A big part of muscle function is calcium. You need calcium to elicit contraction and bind to our contractile filaments, and you need Circa to get rid of it to allow for relaxation. When you have too much calcium, it can cause a lot of problems in the cell, ultimately leading to like cell death and then atrophy. But the actual mechanisms behind that faster loss of function as opposed to mass was still pretty unknown. So that was a big driving force for this study.
And so why is it that a lack of gravity leads to these pumps sort of becoming dysfunctional? Yeah,
that's still a little bit of a mystery. Circa is highly, highly susceptible to reactive oxygen and nitrogen species. It has a lot of susceptible residues that can cause damage and dysfunction to it. So we are speculating, obviously a lot more research needs to be done here. We're speculating that specifically in the soleus, because it's such an oxidative muscle, when you unload it, there's excess oxygen floating around, making it possible to create these reactive oxygen species. That, along with the radiation that space brings, there's a lot of radiation up there that would cause an increase in reactive oxygen species as well. We think that'll lead to Circa dysfunction. Circa dysfunction causes more calcium, which just creates like this vicious cycle of ROS production, basically.
So you kind of touched upon what I was going to ask next there, which is this something we see in sort of stressed states generally? Can you mimic this without the lack of direct gravity?
Yeah, I mean, there's a lot of ground-based models looking specifically at spaceflight. So you can do hind limb suspension. You can do tenotomy, where you basically just cut the tendon. You can reproduce it. There are I think it's called the SOD2 mouse. That is a kind of oxidative stress mouse model that you can use. And they see very similar effects on Circa in those models.
So again, that was one of my next questions. So how do you get into sending these things into space? Is this a situation where these animals have actually gone up into space? Is this so one of those experiments that the ISS do? Or is it just like you shoot them up there and then they come back down and you gather them back up? Little mini rescue operation.
So these mice that we worked on specifically, the missions were back like a few years ago. The one was in like 2016, I think. And it was run by NASA's Rodent Research Center. So RR1 and RR9 are the Rodent Research Center missions 1 and 9. So they're the ones that kind of did that. We were not involved with that at all. They kind of organized that. I think I could be wrong, but I'm pretty sure they went up on like one of Elon Musk's satellites or rockets. And then they are taken in by the ISS and they live on the space station for about 33 to 35 days. And then they're sent back down and collected, basically.
So would you see differences between those that have been up there for sort of 30 days compared to ones that went up longer or shorter? Is this something that gets worse with time?
Yeah, there have been studies looking at, I think, one of the longest was 90 days. of spaceflight. Specifically comparing, I'm not sure if that's been done because typically they send all the mice up on one mission and bring them all down at the same time. So I'm not sure if there's ever been a direct comparison. I would assume, if I had to speculate, that it would probably get worse at the longer you keep it unloaded. I'm sure it would plateau at some point, but compared like 30 to 90 days, I would assume that it would be worse.
And what kind of control do you have for this? Is this something where you've just got rodents that are kept on Earth, or do you have little, are they running around in wheels up there like astronauts do, trying to keep fit?
Yeah, there's so we had two control groups, or we.
Please say one of them was running around up there.
So the one was a ground control. They were in the same cages as the flight group. So they were specially designed cages that allow them to run around on all sides because there's no gravity. So there was caging on all sides. So we had mice on Earth in those same cages to make sure that wasn't any sort of issue. And then we had vivarium controls, which were just in regular rodent housing. So we were able to compare those three groups.
That just makes me sad. I really want a mouse up there on a mouse wheel running around. So I mean, this must be why, or at least part of the reason that astronauts have to train, right? So I mean, it's been known for quite a while that they lose muscle mass. But yeah. Is it muscle mass, or is it that they're losing muscle strength?
It's both. It's both for sure. Astronauts have to dedicate a lot of time to exercise while they're up on the ISS. That is a significant amount of time that they do, mostly resistance training. So yeah, they're trying to counteract that loss, but ultimately it's not enough. When they come down, they still have a lot of atrophy. They still have weakness. I don't know if you've ever watched astronauts come back to Earth, but they can barely stand.
Yeah.
That pull of gravity is quite a bit for them. It's not even just muscle. The cardiovascular system gets pretty badly affected. The fluid shifts upwards. So again, like your veins, your heart doesn't have to pump as hard to get blood around the body in space. So there's all sorts of different effects that happen that we haven't been able to fully counteract with any interventions yet.
Yeah, that constant exercise is definitely the only reason I could never be an astronaut. Definitely just that. Now, one of the really cool things that we tend to dismiss, or rather not look at often in science, is the difference between males and females. But this is something you have looked at and you did find. So could you tell us a little bit about, so were there differences?
Yeah, there were. It's hard to say. We were very limited in sample size with our females. So it's hard to make any conclusions. We did similarly see impaired circa function. We saw impaired calcium uptake in both males and females, but we saw differences in circa regulatory protein content. So some of the regulators didn't actually change the same way as they did in males. And same with the reactive oxygen species. We didn't actually see as much of an increase in females compared to males. Again, we only had an N of 4, which is not ideal. Like we did comparisons between our two control groups and ended up kind of collapsing them together to increase power, but we still weren't seeing the same effects. But again, with an N of 4, it's really hard to speculate anything. They were also on different missions, so they were run at complete different times. So that could play a factor. So we definitely have talked about how important it is to send up males and females at the same time under the same conditions, all that.
So presumably on the space station, they don't, I don't know. Do they experience the same kind of circadian rhythms that we do on Earth? Because I imagine not.
Yeah, that's a really good question. I would also assume not. But I am not super well versed in circadian rhythms and stuff like that. But
on the ISS, do they have like a light dark cycle they go through themselves, or is it just they kind of block the little portholes up to have a sleep?
Yeah, I'm pretty sure that they would go under that 12-hour light dark cycle the same way that they would here. I would assume so, but that again, I'm not certain on how that was run while they were up there.
So, I mean, I know you weren't directly involved in the NASA stuff, but presumably because everything on the ISS is very, very controlled, they must have been like a little ground crew just for the rodents, right? They must have had their own little mission control.
Probably, yeah.
That's a cool job.
Yeah, it's a pretty big, I don't know what the word is, like project that they run. Like the Rodent Research Center, I think is very big and there's a lot of people involved in it. When they spend the money to send mice up in space, they try to take as many measures as they possibly can. So I know when they come down, they're doing like gait measurements, they're doing like neurological stuff before they end up taking any sort of muscle, bone, adipose, any sort of samples. So yeah, I would assume they would have like a little mission control, specific people that astronauts could talk to if there were any issues, anything like that.
Is this something where there's the scientists at NASA who are planning these experiments out, and then it's that you can kind of come along and you can collaborate with them to get the tissues and do your own sort of experiments after that? Or is this something where they kind of think about the whole process, so they think we want to do this with the tissues, and then they send it off to someone like you?
Yeah, typically I think they run these missions. They just get the samples, and then it's not necessarily a bid, but PIs kind of send in their proposals and say, this is what we want to look at. This is why we think it's important. And then NASA will choose what they feel is the best use. So if you dive deep into the space literature, you'll see a lot of people have like RR9 tissue. There's a study published on like thermogenesis in adipose tissue from these mice. People are doing stuff with like the brain tissue. We got some of the muscle. We got some bone as well, which is like another lab at Brock does that. But yeah, I think they just run these missions and then kind of decide after.
A lot of the stuff you looked at is at the protein level, and I might be talking nonsense, but I don't think I am. I think, that's my understanding, if I'm completely not horribly wrong, astronauts do undergo sort of epigenetic changes while they're up there, and there's going to be obviously genetic changes associated with that. So is that something you've looked at? Is that something that might be underlying some of this? Or is what you're looking at all happening at the sort of protein regulation level?
Yeah, we specifically haven't looked at any gene regulation. I definitely know that's a thing. I think there's been a study that found that there are certain gene changes that get passed on to offspring as well. So going into that epigenetic thing, we specifically are looking at the protein level. In collaboration with this work, we also look at an enzyme called GSK3 and whether inhibiting that enzyme can kind of cause protective effects. So that's another kind of side study that another person in my lab is doing right now. But in terms of gene, we don't typically do that. We're more protein people.
I mean, that's where I'm moving into. Proteins are much cooler than the gene stuff.
Yeah.
Genes have been done. Time to move on, folks. So, as I'm sure most people will already know, we have two types of muscle. And did you look at the two types of muscles? Did you notice any difference between those?
Yeah, so we've got fast and slow twitch muscles in a general sense. So the soleus being a slow twitch muscle, meaning it's not used for like explosive movements. It's typically, again, like I mentioned, defying gravity, keeping us upright, as opposed to our fast twitch muscles. So we looked at the tibialis anterior, which is up front. It allows you to flex your foot. And that is typically a fast twitch muscle. It's not really holding us up. It's used for more explosive movements. We did see some very interesting changes. Fast twitch muscles, specifically the TA, haven't really been looked at before with spaceflight. So we are very grateful to have gotten those samples. And we actually saw improved circuit function, which was very interesting. We still saw some atrophy, but circuit function was actually improved. We had faster calcium uptake, which was very, very interesting to see. But it makes sense based on its function. It's not being unloaded. It's not experiencing that same oxygen excess. And that allows for that shift towards a faster phenotype and just improved function overall. Of course, we're missing some contractility data. That would be really cool to do, to see like actual muscle function, see force production. But based on what we have, it looks like we have improved muscle function.
So when you're following this up, or I mean, I guess if you get reviewer comments, you can kind of deal with those because they're not expecting you to send more animals up there. But when you're trying to follow up this kind of work, do you have to wait for more missions to go up, or is the tissue that you can say, well, can we use this to follow up?
Yeah, I think our plan, at least what we've kind of discussed as of right now, is hopefully, people like this work enough that they'll allow us to pitch some ideas. There have been groups send up like knockout mice to the ISS. So we would love to do like a circa overexpression mouse model, see if that prevents that atrophy, even there are pharmacological circa activators that actually very recently published have been shown to prevent aging related decline in muscle mass and function, as well as that oxidative stress mouse model. So using like a pharmacological circa activator would be a really cool next step. But otherwise, we would have to wait for more tissue if we're not able to send up our own.
And so you mentioned sort of differences in potentially with aged mice, aged rodents. With William Shatner going up today or yesterday, whenever it was, this week, when he went up. This week of recording, that is. It's like this isn't going to come out for like 2 weeks, so old news by then. But William Shatner went up there. He's the oldest person to ever go to space, if you count what they did as space. Some people seem not to cause controversy. But so presumably your sample must be all relatively age matched. And I assume they must be sending up different ages in order to get age-related data. So is this something else you could get hold of and look at?
Yeah, that would be cool. I'm not sure if they're sending up aged mice at this point. Most of the time they're sending them up at about 10 weeks of age, because then they're up there for about a month before they come back down. So they'd be like that nice adulthood. But aged mice would be really interesting. Spaceflight is like an interesting analog for aging. It's almost an accelerated aging model with what you see in terms of bone loss, muscle loss, stuff like that. So I feel like instead of sending aged mice, we would almost want to use these mice, spaceflow mice, and see if we could prevent age-related decline on Earth, as opposed to seeing what happens to aging mice in space. But regardless, interesting concept to look into.
See, I just now want to come and work with you guys because I really want astronauts to have to do what I do for a living.
Can I just ask? So I know you mentioned the SOD1 mouse and like all of this stuff about aging. Do these mice actually have like motor neurons disease when they get sent up? Is that like, because that's what SOD1 mutants are in ALS, right? And motor neurons disease. So I didn't know if there was like, they've actually had, I don't know, do they actually have some of the phenotype when they go up? Does it get worse? Does it get better? That would be.
Yeah, I don't know. That would be very interesting though, to see if they already have like impaired neuromuscular junctions, stuff like that, if that would get worse with unloading. I'm sure they could do that on Earth with like the hind limb suspension or the tenotomy and see what happens. I know that there have been studies, I think it was in rats, and they unloaded the muscle, but they stimulated it while it was unloaded to see if it prevented any atrophy that they saw. And I could be wrong, but I think it did actually help attenuate the loss in muscle mass a little bit. So looking from the other side, if it's already kind of impaired stimulation, I wonder if that would get a lot worse.
You know, I've tried so hard not to ask any immunology questions so we can get an episode where we don't bring it back.
It has SOD1. That's ALS. Come on, I gotta ask.
So that space, really cool. And biology in space, even cooler. I think Brian Cox needs to move aside.
Where do I find out about the different bioarchive licenses? This CC, BY, CDXY nonsense is driving me nuts.
ASAP Bio have a resource for that.
Ugh, that's your answer to everything.
That's because they have everything you need to know about preprints.
Sure, they probably have the basics, like info on the preprint servers, but what else is there?
There's so much more. Looking to post a preprint but not sure what different journal policies are? They have a collection to help you out with that. There are meetings around preprints and associated services. If you want to know how preprint adoption has changed over time, there's even a page on that.
And COVID?
They have a big section on preprints and the pandemic, plus some really cool infographics for communicating preprints.
And university policies? Surely they don't have that.
They collect uni policies where possible.
Okay, they do sound pretty impressive, but is it not a bit of an echo chamber?
It can be, but ASAP Bio also engage with people who don't love preprints and have concerns. So we had an excellent discussion on this very topic a couple of months ago.
Oh, is there anything ASAP Bio don't do?
Honestly, no, they're so nice over there. They were so quick to jump in and support this show. It's your one-stop shop for info on preprints and open science initiatives, so head over to asapbio.org to learn more and subscribe to their newsletter for the latest in preprint news. If you want a deeper dive into the world of preprints, then look out for the next recruitment of ASAP Bio Fellows. So one of the other things I'd like to talk about is just sort of general academia experiences and preprints in general. So one of the things I think we've asked everyone so far is, how did you find the process of preprinting?
It was insanely easy. I did notice, it kind of sucked. I did notice looking back that we had messed up a couple of things in the document that we then fixed, which is kind of too bad with the preprint. But I couldn't believe we uploaded it and it was up by like the end of the day. It had been tweeted. I think you were one of the first people to also tweet about it very quickly after it went up, which was a really cool experience to have that much kind of, I don't know if publicity is the right word to say, but attention so quickly. Whereas, you know, the manuscript process and peer review process is a long and horrendous one. So it was a refreshing thing to be able to upload it that quickly and have it be able to be read by fellow scientists so quickly.
Yeah, I mean, I'm very surprised by how quick it is. So the paper we put in for revisions today, that's been in review for like 6 months, but that's been our fault. But I submitted that to bioRxiv at lunchtime today, and within 4 minutes, it was already accepted. It was
Yeah,
up by
I know.
an
It's
hour
crazy.
later. It was amazing. So whose decision was that to preprint? Was that your decision or was that a PI decision?
It was kind of a blended decision. I was applying for some scholarships, and obviously publications help a lot on the CV. So, fun story, I also have a paper that has been in review forever, with revision after revision after revision. And a lot of my work that's happening kind of relies on that paper being published. So I don't know if you remember reading, but neuronatin is my main focus. And we did look at that in this paper. But because we can't cite my paper showing that it's a circuit regulator, we can't really publish this one yet. So we decided to throw it up as a preprint. We could just say manuscript in progress, and I can put it down on my CV as a publication to then apply for grants and scholarships. So that was the main reason that happened, or I guess two reasons.
I mean, that's the thing I usually shout about as being one of the best things. So, I mean, in the UK, at least now, all the funding bodies require you to, or they accept preprints now. Is that also true where you are? Because I know the US is a bit iffy on it.
Yeah, from what I understand, so these were kind of government grants that I was applying for, and they do allow you to say preprint, and they just want like a link basically so that they can actually see that it's there. So they're pretty well accepted here. That and like abstract publications are always good and stuff like that. So lucky about that.
And so with all the traveling you've done, one thing you have done is you've stayed in the same place academically. Yeah. So is this you now looking to, I mean, well, actually, are you staying, I mean, you're applying for grants, but is your long-term plan to stay in academia?
Yeah, as of right now, it is. I love teaching. We all have to TA. I'm assuming that might be the same over there. No? Okay.
No, we don't have to. We also don't get very long for our PhDs though. So.
Okay, fair enough. Yeah, once you enter grad school here, so master's or PhD, you have to TA courses. So I learned that I love that. I love teaching, especially stuff I like. So I love that. I love my research. Obviously, I've stayed in it for a few years now, so I don't really have a plan on leaving. The professor job is pretty good over here. It seems like something that's appealing to me, so that's my plan for right now.
So are you planning to travel for your postdoc? Well,
probably.
Whatever's next anyway.
Yeah, I do. I am going to be applying for a grant to be able to travel to a lab wherever to learn some new techniques and stuff. So I'm hoping to go overseas to Europe somewhere and do that. I have family over there, so I'm always intrigued to come over. But yeah, postdoc seems like a really great time to be able to travel as well as learn new techniques and, and find a new lab, find a new space. So that's the plan.
Yeah, we've all traveled within the same country.
I was going to say, where's Johnny going with this? We haven't travelled.
We've gotten progressively further south within that country.
I've gone west. Almost in a straight line.
You've just shifted slightly to one side.
Latitude-wise, I haven't gone anywhere.
So we also like to talk about general academia, what it's like to be an academic and what the problems are in the system. Because one of the things, or one of the reasons we sort of started this was to switch the focus from PIs onto postdocs and PhD students who actually do all the work and never get the credit we deserve, is my line anyway. Although if you say that, it just causes you trouble. But I don't think we do get the credit we deserve. So we want to try and sort of shine the light more on those kind of folk. And we one of the questions we ask when we have people on is sort of what would you change? What do you think works, doesn't work, that kind of thing. And you mentioned something that is quite relevant to the work I've just submitted today, actually. And that is talking about sort of science communication and accessibility. And so obviously the pandemic has really highlighted this, and that there's a massive problem between what we do as scientists, what the media do as journalists, and what the general public do as members of the general public and their understanding of what we do and what the journalists communicate that what we do. And that's not a necessarily well-connected line all the time, which has led to certain US presidents, ex-presidents, making ridiculous claims, or even Nobel Prize winners making utterly ridiculous claims. And they really will sue me one day for all of this. They just need to start listening. Emma and John have nothing to do with anything I say. So what do you think we need more of, or what can we do better to kind of make science more accessible?
Yeah, I mean, things like this, like just podcasts, YouTube videos, stuff like that help a lot. It's great practice for me to be able to talk about my work to people that don't know muscle, that don't do muscle research. I'm lucky enough to have a lot of family and friends that are not in science. So they're always asking me, what did I do? What did I find today at the lab? All those fun questions. So I've gotten used to
Why are
doing
you
that.
crying in a corner?
Yeah, those fun questions.
My mom used to ask, "Are you still working on that protein?" I'm like, "Yes, ma'am. Yes, I am."
Yes, that's the
my
one.
my
Yeah.
my mum still thinks I'm just doing a course at university.
Yeah. Oh, what courses are you taking?
Yeah.
No.
How many
Um,
mosquitoes have you killed today? I get quite a lot, you know.
oh yeah, that's a good one.
As if you count each one.
Yeah, I got sidetracked. What was the question? How to make things more accessible.
Yeah.
Conferences are a great way to do that. Brock is really cool. They always run conferences for grad students at the university. So it's literally any grad student in any department in the university. So that's a great way to practice presenting, getting things down to the level of like a social science student or a history student. So that's a great way to do it. Even like writing reviews and papers in general, they don't always have to be crazy scientific. That seems to be something that, I don't know, people get lost in their own research. And it's like not everybody is a muscle expert that's going to be reading my paper. So there's no need to dive into all these crazy nitty gritty details, sum it up nicely in a conclusion paragraph so everyone can kind of understand what's going on. Yeah, I think there's a lot of ways that we could change that.
I mean, do you get actively taught how to do SciComm stuff? Because certainly in the UK, the way our PhD programs work is that you're in the lab and that's it. There's no once you start your PhD, you're going to get your PhD basically. You don't have to pass any prelims or anything like that. You're just straight in there and then out the other end pretty quickly afterwards. We don't really have like a formal training program or anything like that.
Okay. Yeah. So our master's program is typically 2 years. Your first year, you take courses that are generally related to what you're doing. A lot of the courses that I took, actually almost all of them, required us to write like a lay summary of our master's thesis. So that was a really good opportunity. Our PhD, you have to take a couple courses as well. The one I'm in now is just like a seminar course, basically, but it's PhD students in the Faculty of Applied Health Sciences. So there are some people doing stuff like me. There's people doing human research. There's people doing like sports management even. So we're all together in this and everyone has to do a presentation. So that's another time when I'm going to have to present my work, but in a very low science way, like get everyone on the same page and get through that. So I think it is relatively well taught. Even throughout my undergrad degree, we were always writing like lay summaries, lay proposals, doing stuff like that. So I feel like it is fairly well taught around here.
Yeah, I don't think I ever did anything lay related in my undergrad. Might have in my master's. And then PhD was just kind of outreach stuff.
Yeah.
I was just going to say, yeah, I don't think I did. I mean, I could be misremembering. I don't think we did much lay stuff. Anything that I did that was kind of more lay was of a personal choice, like why I did like demonstrating. So I was helping undergraduate students out in labs, and I did like a 3-minute thesis thing where it was like a presentation to kind of explain your thesis in 3 minutes to a lay audience. It was never really compulsory within our department. I think
I've done more lay related things now than ever. I've written quite a lot of lay stuff over the past few months. And then like the past few papers we've always had to do a lay summary as well. And grants. Turns out on grants, you got to do a lay summary.
Yeah, so I had to write for a grant I've just written, which was quite good, was I had to write a lay case for support. So I had to write the case for support, which was all the scientific one. And then so that was 6 pages. And then I had to write a 4-page lay case for support, which was actually got me thinking quite a bit. But I don't know whether I've just started noticing it more, but I feel like maybe it's become more popular to do.
I think it has. Yeah. I don't think, certainly for the grants, they never used to necessarily require that.
Yeah. Everything I've ever applied for has been like I have to do like a lay abstract or a lay summary or write my whole grant just in lay terms. So that would take I don't know if that's new.
So related to sort of science communication stuff is the flip side of that is disinformation. So I mentioned Nobel Prize winners in trouble. So what about disinformation? How can we kind of tackle that? Because I think a lot of scientists don't view that as their job, which I disagree with. But it's also not an easy thing to do because you tend to get a lot of, Twitter, great platform, but if you disagree with someone who, say, is against vaccines on Twitter, you're going to get a lot of blowback for doing that. So how do we get into that realm? Can we get into that realm?
Yeah, that's a great question. That's definitely tough. things like Twitter and social media in general, I feel like it's almost impossible to try and fight misinformation there. You just get bombarded with angry people, or they'll just block you. So that's a tough one. I feel like, I mean, these are times when the peer review process is really good. It keeps you in check for sure on your own assumptions and biases towards things. That's when preprints might maybe be an issue. People can kind of throw up whatever, but that's a tough one to fight it. I'd say just keep fighting it. That's the only way to really do it, and hope that at least somebody listens to you. So
yeah, I guess if you convince one person, it's a win. Yeah. Okay, have I missed any questions? I think I've covered everything. I think I've got everything.
Yeah, I think you got everything and more.
I don't think I got it in necessarily the best order, but I think I got everything. It was fun, right? We talked about space.
Absolutely.
I'm really intrigued. Did you ever get to go visit NASA or anything? Or was it just you get the samples and then that's it? Or did they invite you to like our collaborating labs, come have a look around?
We did basically just get the samples, unfortunately. I would love to go one day and
I know, it'd be
see.
awesome.
I'm sure there's not much to see, honestly. It's probably just like a big building, but yeah, we haven't gotten invited, unfortunately. But
how many mice experiments have they done? So presumably there must be more mice in space than there are humans now.
Probably, I would assume that's a good assumption. I mean, we got the RR9, so that was the 9th mission that they did with mice, and that was in 2016, I think. So I'm assuming they're just up there, cycling through missions and sending people samples. So yeah,
so there might actually be mice running around on a mouse wheel up there right now.
Absolutely,
my dream might be a reality.
It might be.
They should stick that on a live webcam. We'll all
that would be entertaining. I would watch that.
Okay.
Thank you so much for coming on to talk to us.
Yeah, thanks for
asking. It's been really interesting.
Okay, and that is the show. If you enjoyed listening, then hit that subscribe button for more and leave us a review on whatever platform it is you're listening on. You can reach out to us on Twitter at MotionPod or online at preprintsandmotion.com. Didn't enjoy that? Well, we're all scientists here, so send us your review and let us know what works or what you'd like to hear more of, or less of. But until next time, have a good week.